We need to talk about scale. I mean, not just getting video from your computer to the monitor on your desk,
Right.
but pushing that same signal across, say, entire factory floor or a university campus.
Yeah, and that's where things get complicated. If you try to run a standard copper DVI cable that far, you're just going to have a bad time.
The signal just dies.
It degrades, you get ghosting, or, yeah, it just vanishes completely. Physics starts to fight back pretty hard.
Exactly. So today, we are doing a deep dive into a specific piece of hardware built for this exact problem. It's the NTI ST-1FODVI-L-SCP-MDP DVI extender.
It's a mouthful, for sure.
It is, but what it does is pretty amazing. It's a VOPEX system, and it uses fiber optics to send DVI video up to 1,000 meters. It's about 3,280 feet.
And that VOPEX part is the key, really. It's NTI's whole system for taking one video source, like a flight information computer, and splitting that signal out to multiple displays far, far away.
So like one brain controlling up to 4 different screens a kilometer out.
That's a perfect way to put it.
Okay, but looking at the specs, this is not just a really long cable. It's more of an ecosystem, isn't it? It has 3 parts.
Correct. You have the transmitter, which plugs into your source. Then there's an optical splitter, which is like the distribution hub. And finally, the receivers, which sit at each display.
And the medium connecting all these pieces is where the magic happens.
It is. They've moved completely away from copper. This whole system runs on a single-strand, multi-mode SC fiber optic cable.
Which immediately solves the biggest problem in an industrial setting: interference.
Oh, completely. If you're in a factory, you have so much electromagnetic noise from machinery, from motors. Copper cable acts like a giant antenna for all that RF gunk.
But light doesn't.
Exactly. Photons don't care about an electromagnetic field. You could literally run this fiber right next to a high voltage line, and the video signal wouldn't even blink. That's the reliability you're paying for.
Okay, but looking at the datasheet, there seems to be a catch. There's a trade-off happening between distance and resolution. You hit a bandwidth limit.
You do. The system's bandwidth is 1.65 gigabits per second. So if you keep your cable run under, say, 984 feet, you get a beautiful, crisp 1920 by 1200 signal, WXGA.
Which is great for detailed graphics, high-res stuff.
Perfect for it. But if you need to push it all the way to that maximum 3,280-foot limit,
What happens?
well, you have to sacrifice pixel density to get that reach. The supported resolution drops down to 100:114 by 76 GA.
Wow, okay, that's a huge drop. That's going from a modern sharp monitor down to, like, old-school projector quality.
It is, and you have to plan for it. Look, if you're just displaying a big gate-changed sign in an airport, XGA is perfectly fine. But you wouldn't want to try and read a complex financial spreadsheet from a kilometer away on this.
So you have to match the content to the distance.
You absolutely do.
Now, one feature in here that sounds like a real headache saver is the EDIDE learning. This is basically the system doing an automatic handshake, right?
Yeah, that's exactly what it is. EDIDE is how a display tells a source what it is and what it can do. This system just learns that profile from the monitor.
So the transmitter knows precisely what kind of signal to send without you having to mess with settings for every single screen.
Which is a lifesaver when those receivers are installed in a ceiling or behind a wall-mounted display you can't easily get to.
Speaking of installation, the form factor here is surprisingly small.
They're tiny. They were designed specifically so you could slide them right through electrical conduit before you terminate everything, run the fiber, pop the unit in a tight space, and you're done.
Since we're talking about putting these in tight spaces and shooting light through them, are we talking about lasers? Is there any eye safety concern for installers?
It's a valid question. The optical source is an 850 nanometer VCSEL, but, and this is the important part, it's laser class 1 safety compliant.
Meaning?
Meaning it's considered safe under all conditions of normal use. So you should never stare into a fiber port, obviously, but it's designed to be safe for people working in those environments.
So to sum it all up, what we have is a system that uses light to broadcast real-time video to up to 4 screens, sidestepping all the electrical noise of a factory or airport.
Exactly. But it forces you to be smart about that distance versus resolution calculation. It's an industrial workhorse.
Right.
This isn't for 8K gaming. It's about getting critical information where it needs to go, reliably.
It's just amazing when you stop and think about it. That flight time you see on a screen or a stock ticker or an emergency alert, all of that might depend on a single strand of glass, thinner than a human hair, just doing its job across a kilometer of building infrastructure.
It's this incredibly fragile-sounding link that holds the whole thing together. Pretty cool stuff.